Michio Kaku once said, "Something is wrong, we need to rethink our theories about the universe." Now, the renowned American physicist is once again shaking up the scientific community. The James Webb Space Telescope, JWST, has detected 3 ancient galaxies, each as massive as the Milky Way, and Kaku understands why this discovery challenges conventional cosmology. According to established theories, galaxies of this scale should not have existed within the first few billion years of the universe. Yet, some researchers continue to cling to the 13.8-billion-year-old Big Bang model, despite mounting contradictions. While Kaku has not won a Nobel Prize or made groundbreaking discoveries in the traditional sense, his true strength lies elsewhere. Born in the US to Japanese parents, he has an unparalleled ability to simplify complex scientific concepts, bridging disciplines and making knowledge accessible to the public. His clarity, curiosity, and engaging communication style have made him a best-selling author and one of the most influential science communicators of our time. When Kaku claims that the Big Bang Theory is outdated, he speaks with conviction. Even before the JWST's groundbreaking discovery of ancient galaxies at the universe's edge, he recognized flaws in our current cosmology. He believes that textbooks still present outdated information and that mainstream science continues to promote a worldview that has long been unsustainable. In the 1990s, early signs emerged suggesting that the idea of the universe's expansion might be flawed, but few were willing to acknowledge it. Now, 3 decades later, the James Webb Space Telescope, JWST, is challenging long-held scientific beliefs, forcing a major rethink in astrophysics. The old assumptions no longer hold up, and we may be on the brink of an entirely new understanding of the cosmos. The widely accepted notion that the universe is 13.8 billion years old remains unproven. How can researchers assert this with certainty when none of the measurement methods have ever been definitively verified? Were you taught in school or university that this number is an absolute truth? If so, you were misled. Science has never conclusively proven the Big Bang Theory or the age of the universe. In today's world, scientific theories are often presented as fact, but this must change. For years, physicist Michio Kaku has warned against the overconfidence of researchers. With the JWST, many scientists hope to cement their theories as undeniable truths. They launched the most advanced and expensive space telescope ever built, expecting to confirm their models. The world eagerly awaited its first images. When JWST captured its first deep space image in the summer of 2023, scientists anticipated a glimpse of the universe's earliest galaxies and relics of the population 3 stars, the first to illuminate space. But the results were shocking. The image was breathtaking, revealing thousands of galaxies in stunning clarity. Yet, upon closer analysis, a profound contradiction emerged. Some of the oldest galaxies appeared to predate the Big Bang itself. This directly challenged the long-standing belief that the universe is 13.8 billion years old. Similarly, the assumption that the universe is expanding is also in question. For over a century, scientists have supported this idea, tracing it back to Edwin Hubble's observations of galaxies moving away from us. His findings led to the concept of cosmic expansion, forming the foundation of modern cosmology. However, as early as the 1990s, evidence surfaced that suggested this expansion might not be real. What if Hubble's conclusions were based on an optical illusion or misinterpretation? Yet, instead of questioning the model, scientists continued refining it, facing one discrepancy after another. If JWST has now detected galaxies older than the supposed age of the universe, the expansion model no longer holds. Adding to this uncertainty is the unresolved issue of the Hubble tension, a persistent discrepancy between different methods used to measure the universe's rate of expansion. JWST confirmed this inconsistency, yet many scientists still cling to the expansion theory, treating it as unquestionable truth. Another unproven claim is the idea that matter gradually emerged from nothing. Have you ever considered that our current cosmological model lacks concrete evidence? Before JWST, no one had actually observed the Big Bang, the so-called Dark Ages that followed, or the birth of the first stars. These ideas were based purely on calculations and assumptions that seemed to fit. Now, JWST has revealed 3 ancient galaxies that are as massive and well-formed as our own Milky Way. According to conventional theories, early galaxies should have been small and chaotic, clusters of stars slowly merging over billions of years. Instead, JWST shows that these galaxies were already highly structured just 13.6 billion years ago. If our own galaxy took billions of years to evolve into its current state, how could these ancient galaxies have reached such complexity so soon after the Big Bang? Traditionally, scientists believed that order gradually emerged from chaos, with galaxies evolving through countless collisions. Even today, we can observe mergers leading to larger, more structured galaxies. This process was assumed to have happened over billions of years. Yet, to reconcile the unexpected JWST findings with existing models, researchers are now proposing that matter formed much faster than previously thought, desperately trying to fit these impossible galaxies into old frameworks. Even John Ma, project leader of the JWST mission, acknowledges the problem. Michio Kaku has long criticized the limitations of conventional scientific thinking, arguing that galaxies larger than the Milky Way could not have formed within just 500 million years of the Big Bang. Despite their efforts, traditional scientists cannot escape a fundamental truth: we still don't know how matter came into existence, when it was created, or how old our universe truly is. Has dark matter and dark energy really been proven? It seems that our current understanding of cosmology might have reached its limits. The Lambda CDM model has had its time, and Michio Kaku is here to explain why. In his book, the respected scientist repeatedly points out the flaws in previous cosmological theories. The Greek letter lambda represents dark energy, which is thought to be responsible for the universe's accelerating expansion. But did you know that the existence of dark energy has never actually been confirmed? If it's now clear that previous galaxy formation models are incorrect, this could be proof that the invention of dark energy as a gap filler was a major scientific mistake. The same goes for dark matter. CDM stands for cold dark matter, and together with dark energy, they are said to make up 95% of the universe. However, there is no real evidence for dark matter either. Isn't it shocking that 95% of the universe is explained by a vague theory, while solid evidence is ignored just to preserve these uncertain concepts? Michio Kaku's perspective on the universe is refreshingly different. Despite selling millions of books and being regarded as one of the most prominent interdisciplinary scientists of our time, Kaku remains humble. He's never dogmatic or arrogant in his work and interviews. He consistently stresses that multiple truths could exist and that we can't truly know the full truth until we have experienced or observed it firsthand. Kaku is a quantum physicist, a field that explores the smallest building blocks of matter, aiming to explain the world from the viewpoint of light and the microscopic scale. Quantum physics delves into how tiny particles combine to form atoms and molecules, which eventually create visible matter. Quantum researchers and particle physicists study how the universe's matrix is formed, the forces at play, and the conditions that make what we see possible. One thing that stands out is that the findings of quantum physics don't align with the Lambda CDM model. Traditional science has always rejected this discrepancy. In fact, even figures like Albert Einstein chose to ignore quantum physics because its findings didn't fit their worldview. Uniting these two fields could bring us closer to the truth,